Let me put things into perspective. It's the 90s, and regulators across the world are clamping down harder and harder on emissions. It was only a matter of time until two-strokes would be banned altogether, and the two-stroke off-roading scene was in real danger of becoming extinct. In the US, the smokers had already been outlawed from the street, but California was desperately trying to extend its regulations to trail riders. And if they managed to ban these vehicles, it wouldn't be long until the rest of the country would join in.
Look, the US had always been a big market for Honda, so them not being able to sell off-road two-strokes to the public, that was a big problem.
And Honda's solution to this was a revolutionary, never-before-seen, big smoking rally bike. Why was this the answer though? You'll find out shortly.
L'énorme avantage de ces deux machines, c'est leur légèreté, donc leur maniabilité. Un atout précieux pour les étapes marocaines.
Introducing the EXP-2 test mule. This motorcycle came out in 1995 and its name stood for Experimental Two-Stroke. And in order for them to save the two-stroke world, Honda went all in. They employed the brand new 402cc two-cycle engine, specifically built for desert and endurance racing. They hand-built an aluminium tube and sheet frame in order to make this platform as competitive as possible. They borrowed the subframe, seat and fenders from a CR500 and equipped this mule with a Showa suspension kit. And they did not stop here, because this outrageous power unit also featured a counterbalancer and fuel injection.
And remember, it was 1995, and this was a reality.
Now, Honda had to pick a benchmark. And well, why not pick their biggest and baddest rally bike? The bike that would take riders to Dakar and other rallies around the world. The NXR 750 Rally. And on the face of it, the EXP-2 paled in comparison. First of all, its engine was almost half the size of the NXR, and it showed, because the two-stroke only put out about 54 horsepower.
Which sounds decent, until you compare it with the NXR's 71 horses. But that's where things start to turn around.
Because these two engines managed to both output the same amount of torque, 50 pound-feet to be more precise. Then, the EXP-2's greatest advantage came into play. It was lighter. Much lighter. Like 50 kilos lighter. That's pretty much unheard of. And what this meant was that, effectively, this new prototype had the exact same power-to-weight ratio as the NXR did. And not only that, the two-stroke had much better emissions and fuel consumption, which also meant its tanks could be much smaller while covering the same distance.
Yes, you heard it right. This Japanese two-stroke sipped less fuel than their own four-stroke. And this made it much more agile than its counterpart.
So, there was only one thing left to do. Take the EXP-2 racing. In a surprise return, Honda signed up for the Dakar Rally at the dawn of 1995. The rally covered over 8,000 kilometers, and everyone else was skeptic. Because two-strokes and rallying didn't really mix before. They all expected the EXP-2 to constantly run out of fuel, and well, they were all wrong. Because Honda's prototype proved to be an amazing weapon. For its first time in a rally, it managed to win the sub-500cc class, and even come in 5th overall. And the Japanese didn't stop here, taking this mule to the Baja 1000 and winning its class while coming in 7th overall. And at the Nevada rally, they also won the two-stroke class while coming in 8th in the general standings. With such a huge success right from the get-go, Honda was on a roll, and so it only made sense to stop racing?
Yeah, you heard that right. After spending tons of money on developing this revolutionary platform, Honda just stopped. In fact, for almost 2 decades, they were not to return to the Dakar, which is odd, until you realize.
Look, Honda's goal for this race bike was not winning races. They didn't care if it finished 1st or 10th. That was not the point. Sure, the EXP-2 arguably punched way above its weight, but it didn't matter. Because this bike was not designed to win races, it was designed to prove a point. Its sole goal was to save the off-road two-stroke motorcycle.
When I found out about this, I was a bit confused. I mean, weren't Honda the ones who said that they never built a two-stroke?
They've been quite adamant about them only seeing four-strokes as the future. So why did they care so much? And look, back then, with the upcoming US regulations, most people had lost all hope that they'd ever get another off-road smoker. So imagine everyone's shock when this bike came out. On one hand, you'd be right. Honda was against two-strokes. I mean, heck, Soichiro Honda himself was dead against them since like the 60s or something.
But remember, Honda is a business. And the reality was, in 1995, the smokers were still very much relevant.
The possible advantages of a modern, clean-burning two-stroke were hard to ignore. I mean, these engines were still smaller, lighter, and made use of less moving parts than their thumper counterparts. And at that moment, Honda themselves estimated that roughly half of the world's motorcycle engines were still two-strokes.
But at the end of the day, what made it impossible for Big Red to ignore was the work of one of their own engineers, Yoichi Ishibashi. His research work was so promising that the corporate giant simply couldn't ignore it. Kind of like you shouldn't ignore the subscribe button. Cheers.
Now, what exactly was the problem here that Ichibashi was trying to fix? You see, according to Honda, two-strokes had two big issues. For one, at low RPM, these engines had a tendency to not ignite the entire fuel and air mixture, causing incomplete combustion. And second, this unburned fuel also kept escaping out of the exhaust port, making the passage of emission tests almost impossible. And so, Ishibashi set off to fix the first and biggest problem: incomplete combustion. The core issue is, as fuel entered the cylinder, some of that reached the other side where the exhaust port is located. Now, during a cycle, the engine wouldn't be able to expel all exhaust gases, so part of this fresh fuel would mix with the old gases.
In a way, the gases acted like a barrier against ignition. So when the spark plug fired, most fuel would get ignited, but not this little pocket trapped behind gases.
And to fix this, Ishibashi came out with a controversial solution. In fact, for the longest time, most scientists thought of this solution as a fairy tale. But Honda made it work. As far back as 1992, the corporate giant started a small research project in order to determine if two-strokes could be saved, no matter how. Initially, they went back to research done by Yakov Zoldvich in the 30s, and later by a team at Toyota in the 70s. They first worked on a solution called ARC. But, in fact, ARC was so controversial and went so hard against the regular train of thought of that time
that in the 70s, the American Society of Automotive Engineers turned down the initial publishing of those papers. But there was no way around it. ARC was working.
Shigeru Onishi, one of the engineers behind Toyota's research, actually built a generator working on this exact principle. He would throttle the fuel input into the cylinder in order to achieve this desired arc effect. Now, Ishibashi looked at this, and it gave Honda a promising start. But there was a problem.
You see, this would work on an engine that has to keep one constant RPM level, but that's not the case in motorcycles. And so, briefly, they put ARC aside and started looking at alternates.
And every single one proved to be way too expensive to implement. Sure, these other solutions worked at the time, kind of, but making those products commercially viable would be literally impossible. And so, Ishibashi, Honda's R&D chief engineer, turned back to ARC. He was determined to save the two-stroke engine and published a lot of the research he had done in various scientific papers.
In his view, ARC was essential to keeping the smokers alive. Okay, I keep mentioning ARC, but what the heck is it? This will be a bit technical, but I will try to explain it as simply as I can. You see, when a dose of fuel reaches an exact pressure and temperature, the molecules inside start breaking down into something that's called active radical molecules. That's what ARC stands for, active radical combustion. Now, these active radicals are highly unstable chemical compounds. The thing is, remember those hot exhaust gases that would be left in the cylinder between cycles? Those also contain a small percentage of active radical molecules. And that was the key, because when these molecules combine with the unstable ones from the fresh fuel charge, the resulting mixture would self-ignite at a temperature that's lower than that of a regular air-fuel mix. And because this process auto-ignites by itself, this means that instead of a flame propagating from the top of the spark plug, this fuel charge would auto-ignite all at once, in trillions of different spots throughout the mixture. In a modern engine, the self-ignition property is usually seen as a bad thing because it's uncontrolled, unwanted, and produces what we call knock. But Ishibashi found a way to control and time this reaction perfectly within the cylinder, and turned an undesired effect into a key component of his new engine.
I hear you asking already, isn't this basically how a diesel engine works? On the face of it, you'd be right, because diesels don't have spark plugs. And while the behavior of a diesel and an ARC two-stroke could resemble a bit, the core functioning principles are way different. Because ARC worked on a molecular level, while diesel ignition is much simpler in a way.
That being said, how did Ishibashi manage to do this? The solution is simple yet so complex at the same time. But it's genuinely an engineering marvel. He started by adding a valve to the exhaust port of a two-stroke engine. This valve would basically raise or lower the top of the port, thereby adjusting this opening by up to 90%. What this allowed Ishibashi was to constantly artificially regulate the pressure within the combustion chamber. And this was brilliant. By regulating the pressure, it allowed Honda's engine to control when the self-ignition phenomenon happened and make sure it was always going on at the right time. And this meant that all the fuel inside the chamber would be burning in a uniform manner, resulting in cleaner emissions. But as a side effect, because of this perfect burn, the throttle response and low RPM torque were also greatly improved. Now, this wasn't perfect. You see, traditionally, the ARC process would only work in a really narrow RPM range. Mr. Ishibashi did manage to widen that range a considerable amount, but not fully. The problem was, at the lowest of engine loads, let's say idle, there was so little fuel coming inside the cylinders, and the temperatures were so low that this process simply wouldn't work. And that was also the case at high engine loads, where there was not enough residual charge in the cylinder to mix with the fresh fuel and self-combust. And so, Ishibashi also added a regular spark plug to cover these scenarios. What all this meant was that the EXP-2 could only utilize ARC between 5 and 60% engine load, while its optimal range was more like 6 to 22%, which doesn't sound that great, does it? That being said, this range was exactly the most problematic range of a classic two-stroke. This is where it would pollute the most, not while screaming on the pipe. And so, with this system, Honda claimed that when ARC was engaged, the carbon monoxide and dioxide levels were 15% lower, hydrocarbons were reduced by 80%, and nitrous oxide emissions were down by a whopping 90%. Long story short, ARC was such a revolutionary technology that it truly can be considered the first clean-burning two-stroke motorcycle, and the EXP-2 proved that it could be done. So, what was it like to ride this machine?
Well, some journalists back in the day did manage to get a test ride, and they all said that the bottom end, when ARC was active, was lazy and smooth, with almost no vibrations thanks to the counterbalancer. It lacked the classic two-stroke hit, but that made it very linear and controllable. Now, they did say it sounded a bit like a truck turbo diesel, and it generated a clattering noise at low RPM.
Last day, still too fast for the others, increasing his lead on Acherons by 6 minutes.
Usually, in normal bikes, this would mean the engine was about to explode, but in the EXP-2, it meant things were going well. And it did go, because its power figures were nothing to scoff at.
You see, The real goal of Honda's prototype was to make a two-stroke with the same emissions as a four-stroke.
And ARC was only a part of it. In order to make their lives simpler, the engineers added a pneumatic fuel injection system. The reason for it wasn't actually to cut down on emissions, but to allow them to accurately control the fuel intake with the same computer that controlled the exhaust valve.
In the past, this was actually a bit of a problem because computers weren't really small and powerful enough to make all the computations on the fly, but the technology was finally getting there. They had to employ a wide variety of sensors, from a throttle position sensor, an engine speed sensor, a NOx sensor as well. And on top of that, the computers had to independently control the two electronic fuel injectors.
With today's perspective, this doesn't sound like that big of a deal. But this was the 90s. A two-stroke back then had almost no electronics on it. The jump from that to the EXP-2 was astonishing. And another unbelievable figure was
the cost. The EXP-2 prototypes allegedly cost about $250,000 each.
And according to an article from Dirt Wheels magazine back in 1996, they were told that each prototype actually was worth upwards of $500K. And this is where the problems started. You see, for its time, the EXP-2 was frighteningly complex, needing a lot of electronic systems working together to make it function. Honda did say that part of those were in there just to facilitate testing, but still. And then the second problem was the cost. Developing one-off special edition motorcycles is one thing, but transferring this technology to all of their commercial two-strokes, that was a real financial challenge.
And then, sure, ARC made it so the two-stroke almost matched the emission levels of a four-stroke, but what if the laws got stricter?
When they started the project, they had no intentions of bringing the system on their regular bikes. As it evolved, and the system proved itself, the Japanese changed their mind, and in 1997 they were said to be working on a dual sport featuring this tech.
And they did, coming out with the CRM 250AR, the last iteration of that lineup. And it was a good bike. But how much sense it actually made? I can't know for sure, but I can tell you this new motorcycle was killed after just 2 years.
The end of the EXP project was a bit of a tragic one. You see, Honda worked on this experimental rally bike in anticipation of the tight emission regulations that were going to unfold. That was smart. Unfortunately, what Honda couldn't anticipate was just how tight those regulations would become. When the new rules came out, they were even stricter than anyone expected. And they made the clean-running two-stroke look outright dirty. The EXP-2 was indeed a huge leap in two-stroke technology, but it simply wasn't quite enough.
And then Honda had another problem, and that was called Yamaha.
In 1998, the Blue Team came out with their YZ400F 4-stroke. What this motorcycle did was, it showed Honda that the public wasn't as reluctant to switch. And Big Red was already working hard on their 4-stroke, so having another big project alongside, one that was so uncertain,
it just became too much. And so the ARC project got killed. For good. While researching this video, I kept wondering, why on earth would they develop a rally bike to test this?
I mean, it sounds like the least fitting application for it. And I was right. It was indeed the least fitting one. And that was by design. You see, they chose this 400cc configuration as their test mule because it was the hardest one to clean up. Having a large combustion chamber coupled with a high piston speed, this created some difficult burn characteristics. And that was the point, because if Honda could make this work, any other two-stroke adopting this technology would be much easier to implement. And also, what better reliability test than running this engine for days on end in the most grueling terrain?
The EXP-2, being a rally bike, made the Japanese engineers work harder. And that was exactly the point.
Now, obviously, other than a cool story, there isn't much left of Honda's experiments. It was completely abandoned at the end of the 90s. And while the technology was left behind, it did represent the start of something else, of Honda's Baja legacy. The Japanese repurposed all the tooling and equipment from their experimental rally project into what would become their Baja program. In a way, the EXP-2 was the start of their success in that racing series.
I will end this video with a question I can't really answer. With modern technology, I'm wondering why haven't other manufacturers picked up on this? Maybe because of patents, maybe because of the cost.
I don't know, but I'd be curious if others have tried toying with this idea. Sure, in a way, power valves operate on a similar principle, but they work to accomplish a slightly different goal.
Anyway, no matter what was going to happen with the EXP-2, it reminded me of just how much of an innovator Honda used to be. They were really at the forefront of it, and it's easy to forget their contributions to our modern off-road world.